Okay, dokes. So, Unit 8, the first topic we were talking about finding average value of a function on an interval. This nicely highlighted mean value theorem of integrals. Hopefully the mean value theorem sounds familiar. We talked about it when we were doing derivatives and things. Very similar to the idea, but this time it's just on an integral. So here's your fancy formula definition, and then we'll show you a picture of what it means. So if we have a function f of x that's continuous on the closed interval, then there exists a value c that's going to be in between the interval a to b, such that when I take the integral underneath the curve, area of underneath the curve from a to b, that's going to equal whatever my function of c is, and then times b minus a. Okay, so what does that mean? Let's look at a picture to make a little bit more sense, kind of connection of what's going on here. So on the left here, we have the graph of f of x is equal to 1/2 x squared plus 8. There's a typo there. Anyone know what the typo is if you look at this graph? Is this graph going to equal that? There's something missing.
Negative sign.
There is a negative sign missing. There should be a negative in front of that 1/2 x squared because it's an upside down parabola, right? Okay. And it says the area underneath the curve between the x-axis from 0 to 4 here. When you find the area underneath that, it's approximately 21.3, okay? You can do that with a calculator. You can do that by hand. But what's happening is you're doing the integral from 0 to 4 of your function, negative 1/2 x squared plus 8 dx. That's going to give you about 21.3. Okay, so now mean value theorem of an integral tells us that, okay, well, this area underneath the curve is the exact area, right? But the mean value theorem says that there's going to be a value c. So down here, it's this value, 2.3, where the y value, which is 5.3, times b minus a is going to equal that same area underneath the curve. So again, f of 2.3, that's my c value. C is 2.3. And then if I times that by b minus a, that's my end point and beginning point. So times 4 minus 0. My y value for f of 2.3 is 5.3. So if I take 5.3 and I times that by 4, we also end up getting 21.3. I think it might be a little bit off. It might be like 21.2 or something like that, but it's approximately the same thing, right? So now, if we take this mean value theorem, there's something that comes out really important from that, and what comes from the mean value theorem is this thing called the average value of a function. Okay, so really all we're doing from this mean value theorem is we're going to solve for f of c. And if I solve for f of c, how do I get rid of that b minus a in parentheses there? Divide it, right? So your formula for average value on the closed interval from a to b is 1 divided by b minus a of that integral. Okay, so like what's happening is if I look at this curve here, so all of these y values, if I added all of those y values together and then I divided it by 4, because that's the amount of x values in between, I am going to end up getting this 5.3 value. Okay, that's what the average value tells us. It tells us what the average y value is on your curve of a specific range from a to b. Okay. Okay, let's try out an example. Okay, find the average value of f of x on the interval from 2 to 5. So whenever you see this closed interval here, we can know that this is my a value, this is my b value, right? So my formula from the previous page, I'll just write it up here in case we forgot. It's going to be 1 divided by b minus a times the integral from a to b of f of x dx. Okay, this little calculator here means that this is a calculator use problem. You will need to use a calculator to solve this. But I do want to do a little bit, refresher of u substitution in case we've forgotten it. But yes, if you want to grab out your calculators, please do so. And then we can go ahead and plug all this information into my formula. So we are going to evaluate 1 divided by b minus a, so 5 minus 2, times the integral from 2 to 5 of my function 2x e to the negative x squared dx. So yes, you could just plug this whole thing into the calculator, which we are going to do here in a little bit, but I do want to refresh ourselves on how to do u substitution because it's been a minute, because this last unit we didn't really do a whole ton of it. So if I wanted to solve this integral by hand, what would my u have to be? Negative x squared, exactly right. So u is equal to negative x squared, which means if I take the derivative, what do I get? Negative 2x dx. And then remember, when you're solving here, I'm replacing this dx with my du, right? So I need to do what with that negative 2x? Divide it. So this becomes divide. So now I'm going to replace that dx with this du over negative 2x. Okay, so let's rewrite this here. This becomes 1 over 3 times the integral of 2 to 5. And then I've got 2x e to the u times du over negative 2x. Now, what's going to go away there? The 2x is going to cancel out. And then now we're just left with 1/3 times the integral of 2 to 5. There is a negative down here, so I'm going to bring that out in front. And then of e to the u du. What is the integral of e to the u? E to the u, it's my favorite one. So I've got negative 1/3 e to the u. However, am I going to plug in 5 and 2 for u? No, I got to change it back in terms of x. So this is actually going to become negative 1/3 e to the negative x squared. So I'm going to evaluate this at both 5 and 2. So I'm going to plug in 5, I'm going to plug in 2. When I do that, I'm going to just leave the negative 1/3 out front. So I plug in the 5, I get e to the negative 25 minus, I already have that 1/3 out in front, so I'm just going to plug in my 2. That gives me e to the negative 4. Okay, now if this was a question on a non-calculator portion of your test, this is where we would end. Okay, we can't do anything else. However, I just wanted to do this to remind us about how to do u substitution because it's been a minute. And now what I would like you to do is plug this whole thing into the calculator, this 1 divided by 5 minus 2 of the integral from 2 to 5 of f of x. And when you do that, we should all approximately get 0.006105. Okay, so plug that in, double check that that's what you get for your answer, which should also equal what we got here in terms of e. Okay, now we're going to find our c value, where the average value is equal to f of c. Well, we just found the average value, okay? Our average value is 0.006105. Okay, that is my average value of f of x. And now we're trying to find, well, what c value do I need to plug in to this function to equal our average value? So I'm looking at, well, when does this equal 2x e to the negative x squared? I'm trying to figure out when are those things going to be equal. we're given a y value, we're trying to find the x or the c value. How am I going to solve that? If I don't know how to solve it algebraically, because I don't know how to solve that algebraically, we're going to have to do something else. Any ideas? Graph it. So in your calculator, we are going to graph this in y1, and I am going to graph this in y2, or vice versa. It doesn't really matter. But we're going to graph both of those, and then we're going to see where what happens. Where they intersect, okay? Now, pause for 1 second. I see us all typing. Just pause for 1 second. Look up here and listen to me, okay? This 0.006105. If I graphed the line y equals that number, where is it going to be?
Very close to the
It's
zero.
going to be really, really close to that x-axis, right? So when we're looking at the graph, it might look like there's not a line there because it might look like it's on the x-axis. So you might need to change, depending what your window is, you might need to change your window to just be like, if I had, this is my graph. Let's say our lowest y value is -1, our highest y value is 1. And then the other thing is that we are only actually caring about the answers that are on the interval from 2 to 5, okay? But why don't you change your x values to just be like -1 to 6, okay? So change your window, plug in your y1, y2, and then see where those things cross. I'll give you a minute to try it out, and then I'll kind of show you up here if you're struggling. All right, so again, on your calculator, here is what my two screens looked like, because technically there was like a few intersections happening, and actually I think there's probably even one over here. However, am I going to keep both of these answers? No, because all I care about is from the interval 2 to 5, right? So this crosses at 0, that's not going to be our answer, but this one does cross in between 2 and 5. So x equals 2.59736 is our answer. Did we all get that on our calculator? Very good. Alrighty, so the c value that is going to equal our average value is when c is equal to 2.59736. Okay, give me at least 3 decimal points there. If you give me a few extra, that's fine too. Okay, this next problem is actually kind of just a little bit of a flashback review. Hopefully, after we go over it, it comes back. We are given a table of values, and it asks us to use the left Riemann sum with our 3 subintervals, and then the values from the table to find the average value of f from 5 to 17. So I see my closed interval here. This is A, this is B, 5 and 17. So I'm going to use that average value formula of 1 divided by B minus A, so 17 minus 5, of my integral from 5 to 17 of my function. Okay, but this time, instead of being given a graph or being given the actual function, I am finding the area underneath the curve by using the left Riemann sum, because that's what the instructions tell us to do. So we got to remember how to find the left Riemann sum. Okay, so remember, if you're given, let me just draw a little picture over here in case we've forgotten. If we're given a graph, okay, let's say I have something that looks like this, okay? The left Riemann sum says I'm going to take the first value and I'm going to draw my box or my rectangle, and I need to find my width and my height, right? And then I'm going to continue it. Okay? So if I'm looking at these table of values, my first order of business is to figure out what the distance is between all of my x values. So the distance between here is 4, between here is 3, that was a terrible 3, and then this would be 5. And then if we're doing it with the left, we're looking at the height on the left hand side, so that's the 23, the 29, and the 36. So we're going to go ahead and multiply these numbers together, and then what do I do with that? Add them all together. Okay, so if I simplify this. This becomes 1 over 12. And then I'm going to multiply this. I'm just going to write it out, and then I'll write the answer. So I've got 4 times 23 plus 3 times 29 plus 5 times 36. Type all that into your calculator, which I know you guys can do. You're capable of that. It gives you approximately 29.917. So again, it's taking all of your y values here, right? It's finding the average value of all of those things from your subinterval of 5 to 17. So if you look at all these y values, 29.917 seems to be about in between those, right? Yeah, on average there, I would say it's about accurate. Okay. All right, so that is your left Riemann sum. Hopefully we haven't forgotten that. Next thing, we're going to look at a graph. We're given a picture of this parabola here, and we are finding the average value of the function on our subinterval from 1 to 4. So again, our subinterval here, this is A, this is B. We're going to plug it into our formula. 1 divided by B minus A times our integral from A to B of my function 3x squared minus 2x dx. Okay, we did one of them by hand already. Let's go ahead and just plug this one into the calculator. Plug this in, you should end up getting 16. Let me know if you do not get 16. So if you guys look over here on the graph, do we see a 16 on that graph labeled? Yes, here is my 16. Okay, again, it takes all of these y values from 1 to 4, every single one of them. It adds all of them together, and then it divides from the distance between where you start to where you end. So it divides by 3, and then you end up getting that 16 value. It's the average of all of your y values, okay? So now part B, we're finding what is this C value. I'm trying to figure out what is the C value that guarantees the mean value theorem. Well, it's actually going to be this, but we can do it without looking at a graph, and we can do it algebraically as well. So what we are going to do is we are going to take that 16, and we are going to set that equal to my function f of x, 3x squared minus 2x. And now this just becomes an algebra 1 problem. Okay, what am I going to have to do here just to solve? Subtract 16. So I get 0 equals 3x squared minus 2x minus 16. Now I'm not sure if it was too early for my last class or if they really truly kind of forgot some factoring math here. But however you want to factor this, I'm going to give you a minute. Factor this problem and solve for x. So I've got 3x minus 8 and then x plus 2. Did any of us continue to solve it? The zero product property says one of these two things has to be 0, so I can solve this and I get x equals, 8/3, or x equals -2. Now, one of these answers is correct, the other one is incorrect. Why would I get rid of an answer here? It's not in the interval, that's exactly right. Between 1 and 4 means I'm getting rid of x equals -2. So x equals 8/3 is your answer, which is also exactly what equals 2.67 as a decimal. So hence we did find the correct answer doing it with some algebra. Okay, questions on either of these 3 examples? Okay, next is kind of a free response question that might be similar to an AP style question that you'll see on a test or a AP test. So let's try that one out. Okay. Got milk. We're going to talk about some cows. We got these cows on a dairy farm in northern Indiana. They're milked in the morning during a 2-hour period. Milk from the cows is pumped into a storage tank, and then the volume of milk in the tank at time t is modeled by a strictly increasing twice differentiable function where m of t is measured in gallons and t is measured in minutes. At time t equals 0, there is 300 gallons of milk in the storage tank. The values of m of t are selected in this shown, or sorry, I can't talk or read apparently. They're on the table, yes? Okay, so this first question should be a review. I say should be because it's been a minute since we've thought about just derivatives. Okay. The first question says estimate m prime of 70. Okay, if I were to plot all of these points, if I made like a quick little sketch here. Oops. Okay. I'm going to plot these points on the graph really quick. Okay, so I've got 0. We'll call this 300. So I got a point here. We'll call this 20. And then 780. Oh, I did not do the scale well. That's okay. This is going to be 780. And then we'll call this 50. We'll do this 1640. This looks like it's just linear, but it's definitely not. We'll call that 90, 120. And then let's just call this point's going to be like way up here. And that point's like, I don't know, something like that. Okay? So this is our graph, where this is m of t on the y-axis in gallons. And then on the x-axis is my minutes. So t is in minutes. Okay, I want to know what m prime of 70 is. So 70 is going to be somewhere in between that 50 and that 90. But m prime, so this is my curve of my m of t function, not trying to scale, but you get the idea. But m prime tells me what? What does the derivative tell me at a certain point on this curve? It tells me the slope, right? So if we're looking at 70, I'm trying to find the slope in between, oops, I want to do a red point there. We're trying to find this slope approximately, but I don't know anything about that point. I don't know anything about what the function is. So how am I going to solve it with what I've been given? Yeah, my 90 minus 50, right? So our formula kind of that we're going to look at here to find that slope for m prime of 70 is going to be m of 90 minus m of 50. So that's the y values, right? And then we're going to divide by 90 minus 50. Divide by your x. So y over x gives me my slope. All right, so now I can plug that stuff in. So if I plug in 90, let's see, I get 3360, and I can plug in 50 and get my new y value there. So subtract these, and I get 40 on the bottom. And I know you guys know how to use a calculator. Actually, that gives me about 43 when you plug that in. Okay, but 43 what? If we're talking about the slope at that point, what is my rate, or sorry, what is my units, or what are my units going to be? It's better English. What is it?
Gallons per minute.
Gallons per minute. So I've got 43 gallons per minute. Okay. Now it asks us to explain the meaning of this question, or the meaning of this answer, in the context of the problem. Okay, so I need to tell what's happening. I need to tell what is the time that it's happening at, and then what is it changing by. So our amount of milk, let's choose, yeah, black. Our amount of milk in the tank, if we're talking about a derivative, we're talking about it's either increasing or decreasing at a rate. So would this be increasing or decreasing? Increasing. By 43 gallons per minute. But it's not always increasing at 43 gallons per minute. It's at specifically what time? At t equals, oops, I wrote t twice, 70 minutes. Okay, does that make sense based on the graph that we drew? We're finding the slope there for the first derivative? Okay, wonderful. Okay, this next one is still nothing new yet. It's not talking about any sort of averages. Okay, this next one says use the data to evaluate from 0 to 120 the derivative of m of t dt, and then we're going to use our units and interpret what that means in terms of the problem. Well, first things first, if I have an integral and a derivative, what is that going to end up equaling? Just m of t. Okay? So if I have an integral and I have a derivative, those things cancel each other out. So really what I'm actually going to find for this problem is I'm evaluating m of 120 minus m of 0. So I can grab those values from our table up there. When I plug those in, I end up getting 4250 minus 300, which gives me 3,950. Okay, and if we're talking of m of t is in terms of what unit? Gallons. So this is just 3,950 gallons. So what does that mean in terms of our graph? Well, up here on my graph, this is the point m of 0. This is the point m of 120. What did we just find? 3,950.
Oh, but the difference.
I found the difference between where we started and where we ended, right? That's the difference in the amount of milk that there was at the beginning versus the amount at the end. Okay, so we can just write that out in words. So you can write it a few different ways, but I'm just going to write it like this. 3,950 gallons have been added to the tank. Again, we have to specify what time to what time. So from time t equals 0 to time t equals 120 minutes. Okay, you could have said that a few different ways. You could have said, well, we have 3,950 more gallons from when we started at time t equals 0 to time t equals 120 minutes. There's a bunch of different ways that you can say that. Okay, but does that make sense? Okay, the last one now is where we are going to use a little bit more of the stuff from today. It says, use a right-Riemann sum, that's old, we've done that before, with 4 subintervals to approximate this 1 over 120 times the integral of 0 to 120 of m of t dt. Okay, and then we have to explain what it means, and then we're going to answer the question, is it an over approximation or under approximation? So there's like 3 or 4 different things that we're kind of asking in this question. So let's start out by just finding the right Riemann sum, okay? So I'm going to zoom in quick up here on my table. If we're finding the right Riemann sum, I got to find the difference in my x values. So this is going to be 20, that's 30, got 40 there, and then we got 30. That's my 4 subintervals. And then if we're finding the right Riemann sum, what am I going to multiply 20 by to start? 780. And then I multiply 30 by 1640, etc., etc. So we're going to multiply these numbers together. And then what am I going to do with all those? Add them together. Okay? So that's kind of visually what's happening. I'm going to write the same thing, write the formula down from example 3 here. So we are evaluating 1 over 120 times 20 times 780 plus 30 times 1640 plus 40 times 3,360 and then plus 30 times 4,250. Plug all that in your calculator, and you end up getting approximately 2,722.5. What do we think the units are here?
25.
Oh wait, did I do something wrong?
Oh, wait, no,
No? We're good?
I'm not good with
Why are you guys looking at me like I did something wrong? Are we good? Okay. I don't know. Let's talk about what the units are going to be. What do you think the units are in this case? We think gallons? Yeah? Well, your gut tells you correct. I'll show you why they're gallons. Technically, our 1 over 120, remember, if you're doing average value, that's our X value. So this unit is technically your minutes, right? And then your M of T is your gallons. And again, you're taking that in respect to your minutes. So what happens is your minutes end up canceling out, and then you're just left with the gallons there for your units. So yes, this is gallons for my units there. But let's explain where or what that means in terms of my graph. Again, average value says, okay, if I take all of these y values, every single one of those y values from 0 to 120, I am finding the average y value in between those. So I'm adding all of those up, getting all of those values together, and then I'm dividing by 120 minus 0, or my interval that I'm looking at, to find the value that we just got, which was 2,722. So that's somewhere up in here. Actually, probably a little lower. It's actually probably about where I drew that red line there, okay? A little bit higher than that 1640, but not quite all the way up to that 4,250, okay? So we're finding that average there between those two. Cool. So we can go ahead and answer what that means. So let's explain that in words. So we just found the average number of gallons of milk that is in the tank. Again, specify the time. So from time t equals 0 to time t equals 120 minutes. And then the average number is going to equal 2,722.5 gallons. Okay, so I've answered the explain the meaning. Now we need to answer, does this overestimate or underestimate the actual exact value? So if I go back up here to my graph, and if I were to draw my right-hand Riemann sums in here, that means that I would have a point here and draw my right Riemann sums. So is that going to be an over or an under approximation of my curve there? An over, right? So this would be an overestimate. Because, yes. Now, because if I go back up into my instructions or my problem here, there's one word that's specifically important telling us why it is going to be an overestimate. Any guesses? It's a mathy word.
Twice differentiable?
Not twice differentiable, but it's close to that one.
Function?
Strictly increasing. If my function is strictly going up, right, continuing only up in that direction, never going concave down, it's always going to be, from a right-hand Riemann sum, it's always going to be an overestimate, okay? So that's our reason. It's an overestimate because we have our function m of t is increasing. All right, last example here. Again, we're still finding average value. So find the average value of the function on your given interval without integrating. So you're given a graph here. So we're going to graph it, and then we are going to, instead of integrating, if we're given a graph, how do I find the area underneath the curve? With some geometry of shapes, yes? Okay. So we've got a piecewise function here, so I need to graph this. 3 minus x from -1 to 3. So that means I'm starting on the y-axis at positive 3, and then that negative x means I'm going down 1 to the right 1. And I'm doing that until I get to my x value of 3. but it's got to go all the way to my x value of -1. So that is the left-hand side of my function there. And then if I draw the right-hand side, 2x minus 6. That means at 3, if I plug in 3 for that, what am I going to get? 2 times 3 minus 6, that gives me 2 times 3 is 6, but then 6 minus 6 would be 0, right? So we're going to start at that point here, and then this 2 tells me that my slope, I'm going to go up 2 over 1. So up 2 to the right 1. Should be a straight line. Just do your best there to draw that. Bless you. And then now all we got to do is find the area underneath the curves from -1 to 6. So our average value, eventually we're going to evaluate this. 1 over 6 minus a -1 times your integral from -1 to 6 of f of x dx. And then this piece right here is what we are going to do graphically, geometrically, with some shapes, specifically some triangles. So underneath on the left-hand side here, if I find the area of this triangle, it's got a base of, let's see, 4, so 1/2 times 4, and then a height also of 4. So the area here would be +8. When is the area negative? If it's below the x-axis. Yep. And then if I find the area underneath this curve, this would be 1/2 times 3 times my height. My height here is 6. So multiply those together and I end up getting 9. So simplifying this integral, this becomes 1 divided by 7 times my 8 plus 9. Add those together and divide. That gives me 17 over 7. Or you could plug it in your calculator and get a decimal. But if you are taking the AP test, either of these answers are fine because they are numerically the same thing. Just kind of feels weird to leave your answer like this, but it would not be counted wrong on the AP test. So, questions on that? Good? Okay, again, on your homework, okay, half of them do actually by hand integrating. The other half of them you can use a calculator. I am fine with that. You don't have to show all of your work for those, okay? But please, please, please try them all before looking at the answer key. Got it? Okay, we'll take a little break here, and then I'll give you guys the rest of class to work on your homework.